Hi there, thanks for joining me again. Today I'm going to show you the antenna that I mainly use when I'm out portable. A couple of people have asked me some questions about this antenna because they've picked up that it looks a tad unusual. It's not like a normal antenna that you would see, and that's very true. The reason is that I've had to deal with some customizations and some issues that have come up using an antenna, an Endfed antenna, that wasn't really designed for portable use. As you're probably aware, when you go out portable, particularly SOTA and parks and peaks, sometimes your antennas can take a bit of a beating. And the antenna that I used originally was an antenna designed to be put up at a QTH and sort of left there. So over time, it's succumbed to the ravages of portable use, and so I've had to modify it and repair it and do a few things, and it's turned into a bit of a Frankentenna, which isn't always a bad thing. So I'm just going to run you through what it looks like, how I've got it set up, and perhaps it'll give you some ideas and some things to try yourself. So the first thing is that it started off life as a commercially made antenna from a company called Endfed Antenna back in the days when I wasn't overly confident of building my own, particularly Endfed antennas, so I made the decision to go and purchase one. And after doing so, I made the decision to purchase another one because I thought they were actually really good. So I do have one installed at my QTH on a permanent basis, which works really well. And this, which was my first one, has now become my portable antenna. So as you can probably read there, it does 10, 20, 15 and 10 meters at 200 watts PEP. So it's a typical Endfed antenna, has a balun connector there for the coaxial feed line, and this black PVC or plastic here for mounting it. Normally you have the pole running up and down here and you just strap it to the pole, whereas in this case we don't use a pole when we're out portable. What we normally do, of course, is we throw a rope up in a tree and we haul the antenna up the tree using the rope. So the first thing I'll talk about is my arrangement for that. So as you can see here, I've got a carabiner looped through the top hole in that bit of PVC there, and attached to that is a swivel. So that just swivels around 180 degrees there. The idea being you throw the rope up in the tree, tie a loop in the end of the rope, and just clip that over that loop in the rope. This helps reduce twists and tangles as the antenna gets pulled up. Either the rope or sometimes the coax can introduce some twisting, and the last thing you want is for this to spin around too much as it goes up, otherwise you'll end up in a twisted mess. So that just helps reduce that somewhat. The other thing you may notice here is the radiating element. Originally this guy had a 20 meter copper wire as its radiating element with a plastic PVC strain relief. The idea being that the wire came through the strain relief and then connected onto the electrical connector there. Both the copper wire and that PVC have succumbed to the ravages of portable use, and they're not here anymore. And that's not a criticism of the quality of the antenna. It's basically just the fact that it wasn't really designed for rough handling in portable use, getting pulled up and down trees all the time. So certainly not a criticism there. So what I've done is I've replaced the radiator with some, I think it's 1.2 millimeter stainless steel rope or wire, whatever you want to call it. This is available from most hardware shops. I think I bought a roll of it online, 300 meters for $85 delivered, which is cheap as. I know stainless steel isn't the first choice for a radiating element. Copper wire is probably the better choice, but as my experience suggests, it may not necessarily be the most mechanically reliable piece of material. So the slight disadvantage that you get out of stainless steel, I think, is offset by the mechanical strength that you get out of it, which I've come to be very thankful for. So effectively, the way that this is connected up, we have these turnbuckles here. I'll just disconnect this so you can see it. We have these turnbuckles here, which and I'll get a close up of this for you in a moment. Effectively, it's just a U-bolt and a saddle. The idea being that you loop the wire through, then back onto itself, and clamp it down, and it's all held in place by friction. And it works quite well. I've had this antenna under a lot of strain a number of times, accidentally or through need, and it hasn't given way at all. So it's quite strong. So the idea being that you hook up. In this case, I've just got some strong rope and another carabiner hooked around the mounting block here, and that just hooks into there like that, and that's just nice and strong. Provides a bit of insulation here as well. And in order to connect electrically, I'll just untangle this. What we have here is basically just some hookup wire, which is clamped along with the wire through that saddle there, soldered on the end just to give it some kind of protection. Probably not going to last a long time, but it's something, and it's just looped back on itself so it doesn't pull through, and into just the usual large automotive connector on this end, and screwed into the ballon there, and that's crimped and soldered just for some mechanical and electrical rigidity. So the thing that you need to be aware of here is that the hookup wire is longer than the strain relief. Otherwise you're going to be pulling on that on those connectors, and you don't want that. So that gives it some freedom to move around as well. This is not going to last forever. I will have to replace it at some stage just through wear and tear, but it's simple enough to do, and if it does happen to break in the field, it's a simple enough repair to get you by if you need be. So all very good. Couple of big fat washers there just to make as much surface area contact as you can, and that's screwed down nice and tight so that doesn't move. All very simple, all very straightforward. So that's effectively the feed line end of the antenna. With regards to the other end, I'll just get that ready for you. Okay, so that's just silly. So the far end of the antenna is very similar to the feed line end. Have the end of the stainless steel wire coming through a typical insulator here, and back through the saddle and clamp just onto itself to be held in place. And as I mentioned before, it's very, very strong. You're not going to be able to move that if you've got these nuts done up properly. Just on that, there's no lock washers or anything on here, so once you do it up tight, just put a dab of Loctite or some sort of other super glue on there just to keep it in place. If they come off out in the field, you're never going to find them, so you really don't want them loose. Just a bit of nylon rope here just so that I can hook up to a couple of these other bits of hardware here. Once again, another 360 degree rotating buckle there, and onto a carabiner once again just to help with the twist in the rope there. The reason for the black insulator is that I didn't want to loop this orange rope around steel wire, otherwise over time that would cut through the nylon rope and it would break, so that just helps with stopping that from happening. So nothing particularly complicated there. So that's the far end. Very straightforward. Like I said, just make sure that these nuts are done up very tight, and you won't have any problems. The whole thing goes together on a fishing reel. Very simple principle, of course. Best way to get this set up is to wind it up so that you can put the feed line up first, and as that goes up the tree, the rest of the wire just splays out from here, and you're left with this guy on the ground, which you can then connect up to your rope at the other end and haul up into the tree. Very straightforward. It takes about 5 minutes to set up once the ropes are up in the tree, and you're good to go. Of course, don't forget to hook the coax up. Can't tell you how many times I've gotten everything set up and realised I hadn't done that. So that's it pretty much. Looks ugly, looks terrible, but works an absolute treat and is nice and strong as well. So we've run a few contests with this antenna, and it hasn't missed a beat. We get a lot of good performance out of it. Needs to be probably at least 10 meters high if you're going to use it as a flat top. If you're going to use it as an inverted V, it probably doesn't need to be quite so high, at least at one end. But we have managed to use it as a flat top at about 30 meters, and that really does give it some really good performance. The one thing that you do need to be aware of with this particular design Endfed antenna is that the coax is used as a bit of a counterpoise, or at least the shield from the coax is used as a counterpoise, so it needs to be probably about 30 meters long is the sweet spot there. 30 feet long. As I said, having it a good 20-30 meters up in a tree gives it the performance that it needs there, and into a bit of a one-to-one isolator, and then into the radio, and you keep RF away from the radio, and it works really well. So there you go. That's my Frankentenna, as I've dubbed it. So hopefully that's helped answer some questions. If not, please feel free to leave some questions in the comments. I'll get back to you quickly, or as quickly as I can. Please like and subscribe if you think you've learned something, or you'd like to learn more, and I'll be putting out some more videos as time permits. So thanks very much for watching, and 7-3.